This meeting is being recorded.
Hi, Assalamualaikum and good day everyone. Today I'm Muhammad Farid bin Zainuddin, student ID MA19274 from section 01F, and also Muhammad Ridwan bin Muhammad Jaafar, student ID MA19187, section 01F. We will present about the lab 2 regarding free and forced heat convection. Our subject BMM 3531 thermodynamic lab for the heat convection. Let me go for the introduction. The objective of the experiment is to investigate the transfer of heat by convection both naturally and by force. Also to determine effect of fin addition on the heat transfer characteristic. The theory is heat energy can be transmitted by three methods: conduction, convection, and radiation. In this experiment, transfer of energy by means of convection method will be investigated. Convection is the transfer of thermal energy between a solid and a moving fluid. Convection is governed by two phenomena: the movement of energy due to molecular vibration and bulk fluid motion. In generally, convection is of two types: forced convection and free natural convection. When heat is transferred by the circulation of fluid due to buoyancy from the density changes induced by heating itself, then the process is known as free or natural convection heat transfer. On the other hand, if heat is transferred by circulating fluid due to external device such as blower, pump, etc., then the process is called forced convective heat transfer. Addition of extended surface increase the heat transfer rate from a surface to a fluid wherever it is possible to increase the value of the surface heat transfer coefficient or the temperature difference between the surface and the fluid. The use of fin has variety of shape. However, in this experiment, only flat fin type will be investigated. We can see in figure 1 after this. The rate of heat transfer from a surface to a fluid by convection given by Newton's law of cooling, Q-A-H-Tm, where A is the cross-section area, H is the heat transfer coefficient, Tm is the mean temperature. So experiment procedure, let me brief about the procedure of the LS-1717004-FFC for free and forced convection apparatus. How to set up. Number 1, you must place the LS-17004-FFC free and forced convection apparatus on a level table. Adjust the adjustable leveling foot it is necessary. Number 2, plug the 3-pin plug to the 240V AC main power supply and then turn on the power supply. Number 3, switch on the power supply unit K in front of the control panel. Number 4, select the the desired test specimen, i.e. F, G, Q. Take the dimension of the test specimen from the operation manual. Number 5, place the test specimen to the plate heater placement, P. Lock it with the wing nut provided. Number 6, connect the test specimen heater cable to the heater socket which is located at the back of the control panel. Number 7, take the digital handheld temperature probe and meter. Measure the initial temperature T1 in the air duct by putting the temperature probe into temperature point E. Ensure the fan is off. After read the temperature of point E, place the temperature probe to point. They have for free convection. You can regulate the power supply to 50 watt by turning the power regulator I. Keep an eye on the digital power meter J. For every 5 minutes elapsed, measure the temperature T2 at point D and record it into a table. Continue the experiment until steady state achieved, where the temperature reading at point D become constant. Repeat the experiment at others value of input power and test specimen. For force convection, switch on the fan switch M, place the anemometer to the point E. Set the fan speed to 0.2 meter per second. Then regulate the power supply to 100 watt by tuning the power regulator I. Keep an eye on the digital power meter J. Every 1 minute elapsed, measure the temperature T2 at point D and record it into a table. After that, continue the experiment until steady state occurs where the temperature reading at point D become constant. Repeat the experiment at others value of input power and test specimen. Repeat the experiment with different type of test specimen. Ensure the previous heat plate is properly cooled before removing it. So result and calculation will get into our report.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. My name is Muhammad Ridwan bin Muhammad Jaafar. Metric number MA19187. I will continue with the result and calculation. This is the graph for final temperature against time. This is typical graph of air velocity against surface temperature. And here is the sample calculation. Some useful data and Renault number vs Nusselt number graph. We will continue about discussion. Number 1, discuss variation of heat transfer in free and forced convection modes. For free convection, if the motion of the fluid is only due to density difference because of temperature variation, then it's free convection. Best example is boiling of water. Also, if the motion of the fluid occurs without any internal source, best example is motion of outside air due to pressure difference. All the above categories come under free convection. For forced convection, in this mode of heat transfer, some external source like blower is used to cause the motion of the air. Important tip while solving convection problem, if the velocity of the fluid is mentioned in the problem, you can straight away do the calculation for forced convection. If velocity of fluid is negligible, then it is free convection. This is because forced convection heat transfer depends on Reynolds number, which is a function of velocity, whereas free convection coefficient depends on Rayleigh number. Number 2, indicate the difference between laminar and turbulent flows. Moreover, elaborate which one has the highest heat transfer coefficient. By experimentation, it has been found that Reynolds number of less than 1200 describe the condition at which there is no breaking away from the tube wall, which is termed laminar flow. The physical properties of the fluid are the determining factors for the heat transfer in this area, which is inefficient in heat transfer terms. The blue line in the graph is for a smooth tube, while the red one is for corrugated tube. As can be seen, whether or not the tubes are corrugated when operating in a laminar flow regime, corrugated tubes have no positive effect until the Reynolds number is above 1000. At Reynolds number above 2000, there is substantial breaking away from the tube wall, and the condition is described as turbulent flow with significant mixing of boundary layer and the bulk fluid. This is the most efficient area for heat exchange to work in. Next, the effect of extended surface on the heat convection. Extended surface of fin are used to increase the heat transfer due to increased surface area of cross-section in which convection process occur. The fin material should have high thermal conductivity and minimize temperature variation from base to the top. Conclusion. The aim of the experiment was to assess the purpose of the Nusselt number, the Reynolds number, and the Rayleigh number for the horizontal flat plate surface that is undergoes both forced and natural convection. Generally, forced convection is the most effective, if not one of the most effective method of heat transfer, and as such is heavily used in the industry and the home state. This is due to the fact that large amount of heat energy can be transport with the minimal amount of loss. This experiment was only undertaken as the flat plate surface maintained in a horizontal configuration due to time constraint. According to the graph, it is clear to see a direct relation between the calculated values and how these two related to the velocity of the air and fan device. However, the great failure was the result failed to show a clear difference between free and forced convection, and as such failed to determine or prove anything. However, the behavior of this graph is still managed to reflect the theory that substantiates them. Reference. This is the reference that we collect to put in our report. That's all from us. Thank you.